So here we are going to see a series of instruction, and in all of these we are using XYZ, and the order is that X is in S0, Y is in S1, and Z is in S2. So here we are seeing the add, and we have 3 arguments. So that's the syntax. You have add followed by 3 registers. So all of them start with a dollar sign. And the general format of these type of instruction that you see you have 3 arguments is that there are going to be some, let's say, operation or calculation from the second and the third one. So between S1 and S2 here. And then the result going to be stored in the first argument. So this S0 here is that the one that actually has the result of this addition of S1 and S2. Subtract is exactly the same. So S0 here gonna have the result, and the calculation is S1 minus S2. So something like that. The ones that you see add I, the ones that, for example, they have a I here, there is few of them that we have, and all of those, they are dealing with a constant. So that's kind of like an immediate value that you are passing as one of your arguments. And it always has to be this last one. So what happens here, you're adding the S1 plus 1, and then you're storing it to S0. Here we have the multiplication, division, and the remainder. So they're all working the same way. This S1, the operation S2. So S1 multiplied by S2, and the result gonna be here. Divide is the same, and we are only having the integer part. So for example, if you had, let's say 3 divided by 2, so if this was 3 and this was 2, 3 divided by 2, you would get 1 here, because you can only have basically 2 times 1 as your quotient. This one is for the remainder. So if you had, for example, let's say 9 and 5, so this was 9 and this was 5, you would get 4 in S0, because the remainder of the division, if you do 9 modulo or remainder of 5, that's basically it's gonna be 1 5 in that, and the remainder gonna be 4. So the 4 gonna be here. Here we have 2 instructions that only take 2 arguments. So the first one is li, and that's basically is load immediate. That means you are copying this number or storing this number in the register that you're giving to. So it's basically setting S0 is equal to 4. So that's li. And move is basically doing the same thing. So it's the difference is that it's the both is register. So whatever the value is in here gonna be copied in this one. Versus in this one, you actually have to write the actual value that you want to copy. So some of these are pseudo instruction. That means, for example, when you write this instruction, actually the assembler gonna like convert this one to 2 or 3 different instruction. And we're gonna see the examples of that later. So now let's try to look at the more complicated translation. So here we have D is equal to B times 4 plus 4 times A times C. So in things like that you have a series of statements. These are 100% valid if you are doing like C++, right? But in your Mars or in MIPS assembly, as you noticed, like as you see here, if you have a multiplication, we are only multiplying 2 numbers always. Or if we have an addition, it's only addition of 2 numbers. So we cannot have something like this that is multiplying 3 things and then adding at the same time. So it cannot be on one instruction, right? So we have to divide it. So how do we divide that? So here is one example. I mean, you can do it many ways as long as you keep the priorities. Like for example, multiplying is coming before the addition. So first you have to do this multiplication or this one. And after you have this one also, then you can add the result of these two together. But as long as you basically consider that, you can do it in any different way. So for example, one way that is here, we are taking a temp 0, so kind of like a temporary variable, and we are multiplying a times C. and then we are multiplying 4 to the result of that. So then 4 times A times C gonna be in temp 0. And then we are doing temp 1 as in B times B. And then the final result that we have here, we are adding temp 0 plus temp 1. So you see here that each line of code that we have here is actually only 2 instructions that is happening at the same time, versus here we had all of them together. So once you have this one, the translation is pretty straightforward. You just have to know which registers you're using for each of these, and you can look at these to use your addition and subtraction and anything that you need to do the translation. So here, let's look at the answer that is here. So this is kind of given, or you can decide, but this is what we have here. So from A to D and the 2 temps, we have the 4 registers, or the 4 for here and the 2 for the temps. And then we literally convert each of them. So A times C, that's gonna be S0 and S2. So you see we have them on the second and third argument. And then the result is in temp 0, so that's the temp 0 that we have as a result. And so on. So these are basically just following this. Just notice for the multiplication, you can put the number. In Mars, actually, there's 2 versions. If there is mul or multiplication with the I, so this depends kind of specific on the compiler that you're using. But this actually doesn't exist again, but like the compiler will take care of this if you have this number here. If you didn't want to use this and you keep it registered, you had to use another temporary register to keep this number 4. And then you would have that register here instead of the 4 itself. Here is same, nothing new. So we have B in S1. So we are just passing that and saving in temp1. And then at the end, we are doing the addition and storing it in S3, which is our D, the one that we wanted to have.